Imagine standing on a beach somewhere along the American Pacific coast. The sun is shining. The water looks calm. A few waves roll toward the shore. People are swimming. Surfers are waiting for the perfect wave. And somewhere beyond the horizon, ships are crossing an ocean so enormous that the human mind struggles to comprehend its true size. From the beach, the Pacific Ocean can look peaceful, almost harmless, but beneath that blue surface is something very different. An ocean larger than all the continents combined. An ocean containing the deepest known point on Earth. An ocean surrounded by some of the planet's most active earthquakes and volcanoes. An ocean capable of generating waves that cross entire basins, storms that grow into monsters, and tsunamis that can travel thousands of miles. And in some places, the bottom of the ocean is nearly 7 miles below the surface. So how dangerous is the Pacific Ocean, really? Is it actually one of the most dangerous places on Earth? Or have movies, documentaries, and stories about sea monsters made us afraid of something that is mostly harmless? The answer is much more interesting, because the greatest danger of the Pacific Ocean isn't one creature hiding beneath the waves. It isn't a giant shark. It isn't a mysterious sea monster. The real danger is the sheer scale and power of the ocean itself. And once you understand what is happening beneath the surface, the Pacific begins to look less like an empty blue space and more like a planet-sized machine that is constantly moving. This is the story of how dangerous the Pacific Ocean really is. The first thing you need to understand about the Pacific is its size. The Pacific is the largest and deepest ocean basin on Earth. It covers roughly 63 million square miles. That is so large that all of Earth's continents could fit inside the Pacific Basin, and this enormous body of water contains more than half of the free water on our planet. But the surface area is only part of the story. The Pacific doesn't just stretch incredibly far. It also stretches incredibly deep. The average depth of Earth's oceans is around 12,080 feet, but the Pacific contained the deepest place on the planet, the Challenger. Deep inside the Mariana Trench reaches approximately 35,876 feet below sea level. That's nearly 7 miles down. If Mount Everest were placed inside the Mariana Trench, its summit would still be submerged. And down there, sunlight disappears. The pressure becomes enormous. The temperature drops. The environment becomes almost completely alien to the world humans experience at the surface. At depths greater than about 1,000 meters, there is no sunlight available for photosynthesis. The deep ocean is dark, cold, and under extreme pressure. Yet life still exists there. Strange organisms survive in conditions that would be instantly lethal to humans. And this is where the Pacific begins to reveal its first great danger. The deeper you go, the less the ocean resembles the world above. If a human being were suddenly transported thousands of feet beneath the Pacific without protection, survival wouldn't be a matter of swimming back to the surface. The human body simply isn't designed for that environment. The pressure would become overwhelming. The darkness would be absolute. And even finding the surface again would be nearly impossible. But the Pacific has another problem. Most of the ocean isn't even remotely close to the surface world we know. It is a gigantic vertical wilderness, and humans have explored only a fraction of it in detail. In fact, as of 2024, High-resolution mapping had covered only about 26% of Earth's seafloor. That means when we look across the Pacific, we aren't looking at a place we completely understand. We're looking at one of the least explored environments on Earth. And that matters because danger becomes much harder to predict when you don't fully understand the environment. Now imagine traveling around the edges of the Pacific, from the western coast of North America, through Alaska, across the Aleutian Islands, toward Japan, through the Philippines, Indonesia, and down toward New Zealand. You would be following one of the most geologically active regions on Earth. It's called the Ring of Fire. And the name is not an exaggeration. The Ring of Fire is a vast horseshoe-shaped zone surrounding much of the Pacific Basin. It contains more than 450 volcanoes and stretches for roughly 25,000 miles. But volcanoes aren't the only thing happening here. Earth's tectonic plates are constantly moving. Some plates collide, some slide beneath others, and some grind against each other. At subduction zones, one tectonic plate can be forced beneath another. This process creates deep ocean trenches. It creates volcanoes, and it generates powerful earthquakes. In other words, the same geological system that created some of the Pacific's deepest places is also capable of producing some of its most destructive disasters, and that's where one of the Pacific's most terrifying threats begins: the tsunami. Most people imagine a tsunami as a gigantic wall of water rushing toward a beach. But that isn't usually how a tsunami behaves in the deep ocean. A tsunami begins with energy. Often, that energy comes from an underwater earthquake. When a powerful earthquake suddenly moves the seafloor, it can displace an enormous volume of water. That movement creates waves, and those waves can travel across entire ocean basins. In deep water, a tsunami can move at extraordinary speeds. NOAA notes that tsunami waves can travel across deep ocean at speeds comparable to jet aircraft. But here's the frightening part. When the tsunami reaches shallow water near her coastline, the wave slows down. Its energy is compressed, and the water can rise dramatically. The result can be devastating. This is why an earthquake occurring thousands of miles away can eventually become a threat to a coastline far across the Pacific. The ocean isn't simply carrying water, it's carrying energy, and that energy can cross enormous distances. This is one reason Pacific coastal communities take tsunami warnings so seriously, because the danger may begin far beyond the horizon. You might not feel the earthquake, you might not see the storm, you might not even know that anything happened. And yet, hours later, the ocean can arrive with the consequences. For viewers in the United States, this matters. The Pacific isn't some distant phenomenon happening on the other side of the world. The United States has a long Pacific coastline: California, Oregon, Washington, Alaska, Hawaii, and the Pacific Northwest sits near one of the most important earthquake zones in North America. The Cascadia subduction zone stretches offshore from Northern California toward British Columbia. Here, one tectonic plate is being forced beneath another. A major earthquake in this region could generate a tsunami affecting coastal areas. And Alaska is also extremely important. The state sits within one of the most seismically active parts of the world. So when Americans hear about earthquakes, tsunamis, or volcanic activity around the Pacific, They aren't hearing about completely unrelated disasters. They're seeing different expressions of the same enormous geological system. The Pacific Ocean is surrounded by a planet that is literally moving beneath it. And that movement never stops. Now imagine you're hundreds of miles from land. There's nothing around you except water, no buildings, no roads, no nearby hospital, no easy way to escape. The horizon is a perfect circle, and suddenly the weather changes, the wind becomes stronger, the waves grow, clouds build over the horizon, and the ocean that looked peaceful a few hours earlier becomes something else entirely. This is another reason the Pacific can be dangerous. Its enormous size gives storms an enormous playground. The Pacific contains major tropical cyclone regions. In the western Pacific, these storms are commonly called typhoons. In other parts of the basin, they are called hurricanes or tropical cyclones. And some of these storms become enormous. The problem isn't simply wind. A tropical cyclone can generate powerful waves and dangerous surf. Storm systems can send wave energy hundreds or even thousands of miles. That means a storm doesn't have to make landfall near you to affect your coastline. You could have blue skies above your beach, while a storm far out at sea is sending powerful swells toward shore. And that creates another hidden danger: rip currents. Imagine walking into the Pacific on a sunny afternoon. The water doesn't look particularly dangerous. The waves aren't enormous. You swim out a little farther. Then you suddenly realize you're moving away from the beach. You try swimming back, but the shoreline doesn't seem to be getting closer. You swim harder. You're exhausted, and now you're panicking. This is where a rip current becomes terrifying. A rip current is a narrow, powerful channel of water moving away from shore, and it doesn't need a gigantic storm to form. Rip currents can exist on ordinary-looking beaches. They can form around breaks in sandbars. They can occur near piers, jetties, reefs, and other coastal structures. And they can move faster than an Olympic swimmer. That's what makes them so dangerous. The water doesn't necessarily look like a monster. It can look like the calmest part of the beach. A darker channel, a gap between breaking waves. Sometimes what looks like an inviting patch of calm water is actually where water is rushing back toward the open ocean. And once someone is caught inside it, instinct can make things worse. A frightened swimmer often tries to swim directly against the current. But that burns energy quickly. The safer response is generally to stay calm and swim parallel to the shoreline until you're out of the current, then make your way back toward land. The Pacific doesn't need a 50-foot wave to become dangerous. Sometimes a current you barely notice is enough. There's another misconception about ocean waves. We often imagine a wave as a giant wall of water traveling across the ocean. But waves are actually energy moving through water, and that distinction matters. Wind transfers energy into the ocean surface. The longer the wind blows, in the larger the distance over which it blows, the more energy can be transferred into the waves. This is why the Pacific's enormous size can become an advantage for wave generation. There is an immense amount of open water over which wind can act. And when large weather systems persist over huge stretches of ocean, they can create powerful swells. Those swells can travel extraordinary distances. A storm can disappear over the horizon, but its energy can keep moving. Eventually, that energy reaches another coastline, and when deep water waves encounter shallow water, the seabed begins to influence their motion. The waves become steeper. They slow. They rise. And eventually they break. For surfers, that's an opportunity. For swimmers, boaters, and coastal communities, it can become a hazard. For centuries, sailors told stories about enormous waves appearing seemingly out of nowhere. They were sometimes dismissed as exaggerations, but scientists now know that unusually large waves can occur. These are commonly called rogue waves. A rogue wave isn't simply a big wave. It's an unusually large and unexpected wave compared with the surrounding sea state. And imagine encountering one far offshore. There is no beach, no shallow water, no place to run, only a vessel between you and thousands of feet of ocean. A large wave can threaten ships by creating extreme forces, and the danger becomes even greater when multiple wave systems interact. The ocean doesn't always behave like a neat sequence of identical waves. It's a constantly changing mixture of wind, currents, swell, and weather. That unpredictability is one of the reasons experienced mariners respect the Pacific. Now let's return to the Mariana Trench. At the surface, the Pacific can be beautiful, blue, bright, warm, but beneath that surface is an environment almost completely disconnected from our normal world. At around 200 meters, sunlight begins to fade dramatically. At greater depths, darkness dominates. At more than 1,000 meters, there is no sunlight, and hundreds or thousands of meters below the surface, the pressure becomes enormous. Yet there are ecosystems down there. Hydrothermal vents release chemically rich fluids. Some vent systems produce extremely hot, mineral-rich water. Animals have adapted to conditions that once seemed impossible for complex life. The Mariana region is home to unusual geological features, including hydrothermal vents and submarine volcanoes, and this creates a strange contradiction. The deepest parts of the Pacific are dangerous to humans, but they are also full of life. The ocean isn't trying to kill us. It's simply operating under rules that humans aren't built for. That's an important distinction. The Pacific is not a predator. It is an environment, and environments can be deadly without having any intention at all. Now we reach the creature everyone expects to hear about: sharks. The Pacific is home to many shark species: great whites, tiger sharks, hammerheads, mako sharks, and many others. Hollywood has spent decades turning sharks into symbols of ocean terror, but the scientific reality is more complicated. Shark attacks do happen, but they are rare. NOAA has emphasized that shark attacks are often perceived as more common because modern phones, social media, and news coverage can make encounters spread around the world almost instantly. So if you enter the Pacific and see a shark, should you panic? Not necessarily. A shark encounter doesn't automatically mean an attack is coming. In reality, the far greater dangers for ordinary beachgoers are things like currents, waves, sudden weather changes, and drowning. That doesn't make sharks harmless. It simply puts the risk into perspective. The Pacific doesn't need a shark to be dangerous. The ocean already has plenty of ways to overwhelm a human being. But the Pacific's influence doesn't stop at its coastline. It can reach into the atmosphere and eventually affect weather across the United States. One of the best examples is El Niño. El Niño is a climate pattern involving unusually warm ocean temperatures in the tropical Pacific. It changes the interaction between the ocean and atmosphere, and those changes can influence weather thousands of miles away. For Americans, El Niño can mean significant changes in precipitation patterns. The southern United States can experience increased rainfall during some El Niño events. Meanwhile, other regions can experience different temperature and precipitation patterns. This is one of the most fascinating things about the Pacific. You don't have to be standing on a beach to experience its power. The ocean can change atmospheric circulation, which changes weather, which changes rivers, snowpack, agriculture, wildfire conditions, and flooding. A patch of unusually warm water in the Pacific can eventually influence life far inland. The Pacific is not simply an ocean, it's part of Earth's climate engine. Imagine being on a boat in the Pacific. Everything appears normal. But several miles beneath you, magma is moving through Earth's crust. Volcanic activity is happening beneath the surface. Some volcanoes rise high enough to create islands. Others remain completely underwater. The Pacific Ring of Fire contains hundreds of volcanoes because of the complex movement of tectonic plates around the basin. And underwater volcanoes can be difficult to see. There may be no dramatic mountain visible above the waves. The activity is hidden, but it can still reshape the sea floor, and volcanic eruptions can sometimes interact with the ocean in dangerous ways. They can trigger landslides, they can generate waves, they can release enormous amounts of heat and gases. The Pacific, therefore, contains a strange combination of beauty and violence. Islands that look like tropical paradise can be the visible tops of giant volcanic systems. The beach may be peaceful, while the geology beneath it is anything but. There's another danger that doesn't get nearly enough attention: distance. The Pacific is enormous, and when you're far offshore, the problem isn't necessarily that something will attack you. The problem is that help may be incredibly far away. A mechanical failure on a ship, a medical emergency, a damaged engine, a navigation problem, severe weather, a fire, an injured crew member. On land, emergency services can often reach you relatively quickly. At sea, distance changes everything. A rescue helicopter has limits. A rescue vessel takes time. Communication systems can fail. Weather can prevent rescue operations. And the further you travel from land, the more self-sufficient you need to be. This is why ocean crossings have historically demanded careful planning. The Pacific has been crossed by explorers, sailors, commercial ships, aircraft, and modern expedition vessels. But the fundamental problem hasn't changed. Once you're far enough from shore, you are on your own. Experience helps, technology helps, forecasting helps. Modern ships are dramatically safer than the vessels of centuries ago. Satellites can track storms, buoys monitor waves and ocean conditions, seismometers detect earthquakes, tsunami warning systems can issue alerts, weather models can predict storm movement, GPS can determine position. Communication systems can connect ships to the rest of the world. But none of this changes the fundamental reality. The Pacific is still vastly larger than anything humans have built. A ship may be enormous by human standards, but it is tiny compared with the ocean. A person may be an excellent swimmer, but no human can outswim the Pacific. A modern aircraft carrier may be one of the most sophisticated machines ever built, but even it depends on the ocean behaving within certain limits. The Pacific doesn't have to defeat technology. It only has to exceed its limits. This is where the answer becomes complicated. If you're asking whether the Pacific contains dangerous phenomena, absolutely. It contains enormous storms, powerful currents, tsunami-generating earthquake zones, active volcanoes, extreme depths, large waves, remote regions, and countless marine animals capable of injuring humans. But if you're asking whether the average person walking along a Pacific beach is constantly in mortal danger, no. That would be misleading. Millions of people safely live beside the Pacific. Millions swim in it. Millions surf it. Millions fish from it. Ships cross it every day. The Pacific provides food, transportation, energy, recreation, and enormous ecological value. Its danger depends heavily on where you are, what you're doing, and what the ocean is doing at that moment. The same ocean can be completely harmless in one location and deadly somewhere else. That's what makes the Pacific so fascinating. Think about the difference between standing beside a swimming pool and standing beside the Pacific. In a pool, you can see almost everything. You can understand its boundaries. You know where the bottom is. You know where the exits are. The Pacific is different. Its horizon disappears into the curvature of Earth. Its bottom can be miles beneath you. Its weather can change over enormous distances. Its currents can move water across entire regions. Its waves can carry energy across thousands of miles. Its earthquakes can shift the sea floor. Its volcanoes can erupt beneath the surface, and its climate influence can reach continents far from its shores. The Pacific is dangerous partly because it operates on a scale humans were never designed to experience directly. We evolved on land. The ocean is something we visit, and every time we enter it, we are entering an environment governed by completely different rules.
Now imagine this. You're on a small boat in the middle of the Pacific. It's nighttime. There are no city lights. No coastline. No buildings. Just darkness. The stars are visible above you. The sea is moving gently. Then you look around. Every direction looks identical. North. South. East. West. Water. And beneath your boat is thousands of feet of darkness. You can't see the bottom. You don't know what is beneath you. You can't simply swim to land. You can't walk away. You are completely surrounded by an environment larger than entire countries. And that's when you understand something. The Pacific doesn't need to be angry to be dangerous. It doesn't need a monster. It doesn't need a giant wave. It doesn't need a hurricane. The sheer distance between you and safety is enough. Despite everything we've talked about, the Pacific Ocean isn't something humanity should simply fear. It is something humanity needs to understand. Because the Pacific is also one of the most important systems on Earth. It supports enormous ecosystems. It stores and transports heat. It influences global weather. It provides food. It supports international trade. It connects countries and continents. And it contains biological and geological discoveries that scientists are still trying to understand. Every expedition into the deep Pacific can reveal something new. A strange organism. A previously unknown geological feature. A new ecosystem. A volcanic process. A better understanding of how our planet works. The same darkness that makes the deep ocean frightening also makes it scientifically fascinating. If we rank the Pacific's dangers by the things humans often imagine first, sharks might be near the top. Sea monsters would probably be number one. But reality tells a different story. The biggest threats are often much less cinematic. Rip currents, severe surf, storms, boating accidents, tsunamis, earthquakes, extreme weather, isolation, and the simple fact that humans cannot survive indefinitely in the ocean without protection. The Pacific is dangerous because it is powerful, not because it is evil. And that distinction matters. The ocean doesn't hunt us. It doesn't want revenge. It doesn't know we're there. It simply follows physics. Wind creates waves. Gravity creates tides. Earthquakes move the seafloor. Tectonic plates reshape the planet. Storms transfer energy into the sea. Currents move water. And humans must operate inside that system. So the next time you stand on a Pacific beach, look beyond the waves. Look beyond the surfers. Look beyond the horizon. Because underneath that beautiful blue surface is a world of incredible scale. The deepest place on Earth. Thousands of volcanoes and tectonic boundaries around the basin. Powerful currents. Migrating animals. Hidden ecosystems. Storm systems capable of crossing enormous distances. And enough water to cover a staggering portion of our planet. The Pacific can be calm. It can be beautiful. It can be incredibly productive. It can even look completely harmless. But beneath that calm surface is a machine that never stops moving. And perhaps that is the most unsettling thing about the Pacific Ocean. Not that it is always dangerous, but that it can become dangerous without asking permission. A sunny afternoon can become rough surf. A distant earthquake can become a tsunami. A beautiful beach can hide a powerful rip current. A calm horizon can conceal a storm hundreds of miles away. And beneath your feet, there may be thousands of feet of water. So, how dangerous is the Pacific Ocean, really? The answer isn't that it's a death trap. And it isn't that it's harmless. The truth lies somewhere in between. The Pacific is one of the most powerful natural systems on Earth. Respect it. And it can become one of the most extraordinary places you'll ever experience. Underestimate it. And it can remind you, very quickly, just how small a human being really is. Because when you stand at the edge of the Pacific Ocean, you're not standing at the edge of a lake. You're standing at the edge of an entire world. A world that stretches farther than your eyes can see. Deeper than your imagination can follow. And powerful enough to reshape the land itself. And that is the real danger of the Pacific. Not the monsters beneath it. Not the myths. Not the legends. But the ocean itself. Vast. Deep. Unpredictable. And almost unimaginably powerful. The Pacific doesn't need to chase you. You only need to forget that you're standing in its world.